You go to kill.com, then download, then go to product download. You can go here. I send this link here in the chart. So then you'll go to C51. You will give all the necessary information, and finally you can download this. If you click on this, automatically software will download. I already sent the link. Yeah, once it is downloaded, you can go to download folders. This is the software. No need to do anything. Just double click. Automatically do next, next, next. You want to do it yes, then whatever will come next, next you do, it will finish. It don't have any other things. Only first time you need to do yes, then next, 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 and finally you'll go with finish. So that is the first software first you can install now. And if anyone facing problem with the software number one, kill, please let me know. I hope everyone able to install it. Any doubt to install the software number one? Please proceed. And if you're getting doubt, let me know. Then same way, the once first software is you have installed, then what you will do, go to the link, whatever link they have provided, go to download anyway. This software little bit big software. I'm not telling anything. I'm just waiting to download the software. Skill software supported on Ubuntu. Let me check. I have not tried. Let me check. Only install once. It is not telling anything regarding Windows. Install once, we'll check either it's working or not. Not sure. I did not check actually. I don't have Ubuntu in my PC, so I did not check till now. It should work because this is the ARM website. So whatever they are giving, it should work. Okay, so software already downloaded. It will go there. Just same way. First, you have to extract by using Windows software. So once you will extract, you will get this software. Simple. Again, same thing. This is also do. Click, install, next, and finally you will go with finish setup. So both the softwares are very straightforward. So just double click, allow it yes, then you do next, and finally your software will be installed. There are two softwares. One is Kill, whatever you told KIL, one more is Proteus. So for Proteus, I already shared the link here. You can download from that. This is the software Proteus. Already shared the link in the group. Directly you can download from that. So you will get it. And for Kill, you need to go to this website. That also I already sent the link. That also I already sent link. You can check here. Good evening again to all. So yeah, I'm going to share my desktop. Then we'll start from where we left yesterday. Sharing my desktop. Once it is visible, just let me know.
It is visible and you're also audible.
Okay. So I think yesterday we have just created one folder and we have just started with one project. Yeah, we have just started with one project that we gave a LED on. So if you'll go to that code also, you can see here, this is the code we have written yesterday. we just took one LED and we are going to means the main purpose was that just LED was on. That's it. So whenever we'll do this project, uh, you can do how I have done it, or also you can follow how in industry they are writing the programs. Also, whenever you are using any microcontroller board like Arduino board or like any other boards, whenever you are using, you can see they have maintained the code database in a structured way. So same structured way I am going to start today. Now same project we'll do, but we'll do in a structured way. So first I'll go for a structured way, then we'll go for the next step. So same LED on project we are going to do, same thing we are going to do, or you can talk about LED on, or also you can implement any other things. So LED on, I'm going to do. So I'm going to create 5 folders. I'm going to create. It is coming. Okay, I'm going to create here 5 folders. I hope everybody able to hear me. Everybody are following me. Yes. Okay, cool. I'm going to create 5 folder, and this is the name I'm giving. This is the name I am giving. So you can give any name. You can give A, B, C, D, E, F. You can give any name you can give. It's not about that. Whatever name I'm giving, you need to follow that name. You need to follow that name. But in industry, every industry, whatever all the companies are there, whenever they are writing the codes, they are following this structure, this naming converse naming, they are following it. Okay. So I'll tell you why these 5 folders we have created. Okay. Increase volume. This is my increase. I'll go little more loud voice. So we are creating now 5 folders. So these 5 folders, why you are creating? You can give the name A, B, C, D, E. Any name you can give. Whatever name you want, you can give. But these names we are following. The reason is that if you'll see WSP, WSP means this is the workspace. In this folder, you are going to put all your workspace file. In this folder, you're going to put all your workspace file. Then we'll go to app. In this folder, you are going to keep your all application file. You are going to keep your all application file like main.c. So this is your application file. You are going to keep in that app folder. Then bin. What is the bin folder? Now, whatever code we are writing, this code I'm writing. Now, whenever I write this code, your machine cannot understand this code. Your machine cannot understand this code. Your machine can only understand machine readable format. Your machine can only understand what? Machine level language. That is the in the form of binary 0 or 1. So whenever you are writing this code, what will happen? You need to convert this code into binary format. You need to convert this code into machine level format. So how you are converting? By in your kill software, you are converting that. And whenever that file is converting, whenever you are converting that, so whenever you are converting that, so suppose your this is my main, this is my LED folder. LED folder have the main.c. Now this main.c your microcontroller cannot understand. This main.c you are going to convert into binary format. That will be .hex extensions. Either you can go .hex extensions, or you can go .bin extensions, or you can go .exe extensions. So any name depends on the um, uh, what is that? Depends on the tools. It is coming the name extension. Now, once your compilation process is done, once your execution process is done, so this code will convert into hex format. That time, and that time, what you'll do, you are going to keep in which folder? You are going to keep in bin folder. So bin folder means nothing. Bin folder means what? We are going to requesting everyone to double tap. Okay. So this bin folder, what you are doing, we are using to keep our whatever binary file you are going to create. Okay, and src and include, these two folder we are creating for drivers. So tomorrow if you are going to create any drivers, someone yesterday asked me that they have the delay functions. So delay is a driver. Same way, if you are using any Arduino board, you are using so many drivers. Whenever you are sending the data, one driver you are using. Whenever you are doing any operation, you are using any driver. So generally in our training, whenever I generally give training, I don't take any driver from outside. We are going to create here our own libraries, own driver for every modules like timer, counter, serial communications, interrupt. Every module we generally create the driver. So what we will do in this case, we are going to keep inside src folder and inside include folder. So these two folders are for what? These two folders are for driver related folders. So whenever also we are creating driver, in that driver there is one .c file and there is one .h file. So .c file we are going to create in src folder, and .h file we are going to create in include folder. .h file we are going to create in include folder. So this is the 5 folders we are creating. Okay, so again I'm telling, you can give any name. You can give a b c d e, or you can give app bin src include wsp. Why I'm giving these things? Generally tomorrow if you are going to start any microcontroller programming, and whenever you buy any microcontroller, they have some reference things, and if you'll see in that reference, these many files, these many folders will be there. That means suppose now you want to find any driver, so directly you can go src and include folder, you can check the drivers. If you want to find any application file, directly you can go to app folder, you will get it. If you want any binary file, if you want to flash that code into the machines, then that will be there in the bin file. And if you want to get the project, what is that workspace, what is that project, it will be there in workspace folder. So this is for you to know whenever you are whenever you are working with any new controller. So this structure they are following. So same again from yesterday where we stopped, again we'll start from there. Again I'll open the software, Kill Microvision 5, same whatever we have done it. So what I'll do now, I'll go to project. I'm doing again from starting. I'm going to project. Then first what we'll do, new microvision project. So now I have created these things, LED on today. This is the I have created. Now if you'll see inside that, there are 5 folders are there. So whatever workspace file, whatever project file you are going to save in WSP folder. You are going to save in WSP folder. LED on you can keep. Okay. Next. Here, if directly your controller is coming, that is fine. If directly not coming, you can go here. So you can search your controller AT89C51. So click on that, then you can do OK. Again, I'm telling this, you have to copy this starter file. You need to copy the starter file. Yesterday also I told. So why starter file you need to copy? Because inside the starter file, all the configuration they have mentions. All the configuration, like I told yesterday, we have 5 memory segments: heap memory segment, stack memory segment, BSS, data, text. So every memory segment, where it will start, where it will end, where it will start and where it will end, all the information they will take from the startup file. Also, if you want to increase any memory segment areas and you want to decrease any memory segment area, you can change in the startup file. So startup file have all this information. So you have to make it ES fast. So now this is there. Then as I told yesterday, we need to do some settings. Here is the setting. The frequency we are using for this controller is 11.0592 megahertz. Okay. And next point, whenever we are writing the program, that program where you'll store, you are storing in on-chip ROM. You have to tick it. Then output, you need to create hex file. Why? Because your machine can only understand machine level code that is in .hex format. For that reason, I'm telling we need to create hex file, tick on that, and you are going to save in bin folder. You are going to save in bin folder. You are going to save in bin folder. Now, here nothing, then C51. So we are not going to do any code optimization. So what is code optimization? There is a topic is there. So basically, generally, where we'll talk about volatile keyword. So as of now, we are not doing any code optimizations. As of now, we are not doing any code optimizations. And if you are including any, if you are including any drivers, if you are writing any drivers, that drivers where you'll keep the .c file, you will keep in the .c file, you will keep in src folder. The .h file you will keep in include folder. So from include folder, you will take your drivers. So whatever drivers you have, you will take from your include folder. So you just give the path. So wherever your drivers files are there, basically you need to give that path. But as we are following how in industry they're writing the code, so in industry, what they're doing, they are keeping the .h file, all the header files in include folder. For that reason, I'm keeping here. Done. Okay, done. Then I'll create a new file. This is nothing but main.c. This is your application file. Your application file where you'll store in app folder. So main.c. So now this was my yesterday code. Am I correct? Yes or no? Now this is LED on. Now Now, this is the code. Till now, this code is not converted to binary. If you will go to the folder, bin folder, you will not see anything here. You will not see anything here. Till now, we have not converted anything to binary. Now, what you will do, you can convert. It will not happen because this is the application file you have written. It is there in this app folder. It is there in this application folder, but it is not there in the project. You need to add into this project. You need to add into this project. So what you will do, just here right click, add existing files to group source group 1. So now what you will do, it's an existing file, we'll take from app folder, main, then add it. Now this is added here. Now you can see this is enabled. Now this is the compilations. Now I'm doing compilations where I'm seeing 0 errors, 0 warnings. Then I'll click on that. It will, what it is telling? It is telling creating hex file, and where it will store? It is storing in the bin folder on the name of LED on. On the name of LED on. So 0 errors, 0 warnings. So 0 errors, 0 warnings you are getting here. Now, so this is done here. So you can get here this. Now if you go to bin folder, now if you go to bin folder, you will see here. You can see hex file is created. You can also time these things, and this is how possible. This is possible through this platform. This platform only we are creating the hex file in this platform. Clear? Okay, I'll repeat one more. I have I have created selected 8089C51. This is the controller I told yesterday. Okay. So I'll repeat again. We are going to do another 3-4 projects. So don't worry. This process again, I'll repeat it. So now your hex file is created. So now I'll check either your code is working or not. So directly you can debug here. Directly also you can debug here. That will go later. So first we'll go to Proteus. So this is my Proteus. So now this page will come. Once you will create a new project, this page will come. You can see here. So if you click on P, that means what component you want, you can search here and you can take it. Suppose I want my controller AT89C51. AT89C51. So this is my controller AT89C51. You can see I'm just click here and making here. Now you can see here In device, here it is there. So just click on this and here you click on this. You can replace your controller directly here. Just here you click, again here you click. It came here. Then you want one more LED. Again, click on P. From there, you'll pick the device. Then you type LED. Once you type LED, there are so many LEDs are there. You can take one LED for your purpose. So I'm taking animated LED model yellow. I'm taking this LED. So, okay. Now I can see in the left side, this device came here. So now click on this, again click on here. So you can see here now, this LED came here. Now, if you want this LED, you can change the directions, but always this is my positive and this is my negative. So where I have connected LED in my code, I have connected in 0 number pin, port to 0 number pin I have connected. So what you will do, you click here, just drag and drop. Again, click here. Here we are connected. Drag and drop. Again. One more time. Click and we are connected. Simple. One more side, it will connect with ground. From where you will get the ground? You can see here. If you go here, it is taking select. It is telling selection mode. If you go here, it is telling component mode. If you go here, it is telling junction dot mode. It is where level mode. If you go here, it is telling sub circuit mode. If it is telling terminal modes. If you click on this terminal modes, you will see input output bidirectional power ground bus. So ground I'll take from here. Again, I'll just paste here. Then what I'll do? I'll just drag and drop. I'll just drag and drop. So LED is connected. Again, how if you want to take one more device and if you want to connect, how you'll do it? Again, you need to go to component mode. If you click on that, then only this mode will, terminal mode will go vanish. Now, if you click on this, again, it will go to component mode. If you want to take your ground, click on that. If you want to take component mode, click on that. Clear? So, this is the thing. So, by default, in 8051 microcontroller, by default, your port 1, port 2, and port 3 are high. Okay. By default, port 1, port 2, port 3 are high. That means already here 5 volt is there. Already 5 volt is there. If you, till now, I have not given any program here. Just if I'll run it, you can see LED is on because by default, your port 1, port 2, port 3 are high. Okay. Now I'll put the code. Anyway, without the code also, it is on. So how I'll transfer the code? Now I have written the code in the laptop. I have written the code in the laptop. I have converted into machine level format. That is as .hex format. So now what I'll do, I'll double click here. I'll double click here. So now click on that. Now I need to upload the code. That means whatever code is there in my PC, that code now what I'll do, I'll upload into my microcontroller. So this is the microcontroller. I'll double click on this. So I'll go to program files. I'll go to my folder. I'll go to my folder. Yes. LED on. I'll go to bin. You can see only it is taking hex files. Today, 28th created at 6:27. Click on that, then open, then OK. Now if we click, your LED on. Anyway, by default, all the LEDs are that is also on. So what I'll do, I'll just change here. You saw that all the LEDs are by default on. So can you off this LED? Can you off this LED? If you will tell LED equal to 0, now this LED will become off. Now save it, just compile it, execute it. Again, new hex file created. Go here, stop this one, double click here, click on that. Now 634 it is done. So open it, okay, then play it. Is this your LED off now? Yes. Everybody clear? Everybody clear this point? I hope clear, so that I'll go for the next one. Okay, cool. So this is very basic program. I'm not telling that do this program, but this is the very basic program, how you can start your journey. Okay, now we'll go little more. Now I'll tell one more concept. Okay, before going to that, I just want to tell you, if you'll see my chapter number 5, I think. Yeah, chapter number 5, or in chapter number 5, they clearly mention what is that? That you are going to learn here. What? You are going to learn debugging and testing techniques. So first thing is that now this is not my real hardware. This is a software tool, right? Here in computer, I'm writing the code. Again, in computer also, this is my tool where I'm designing it and I'm putting the code. Now, tomorrow what will happen? Suppose you are going to use real hardware. Tomorrow you are going to use real hardware. I must say that already you know about Arduino. Suppose you are using Arduino, or you are using any other microcontroller. So that case, how you will flash the code? Flash the code means whenever you have written the code in the computer, this hex file, whatever hex file is created, that hex file now you are going to put into microcontroller. So how you will do it? So that method is called flashing technique. So that method is called flashing method. So that method is called flashing method. So there are so many devices are there for flashing method. Okay, which one very popular device one is that JTAG. One very popular device is that JTAG. Okay, one very popular device is that is JTAG. So by using JTAG, this device name is JTAG. By using, okay, so how also it look like? So I don't have the real hardware. I also I cannot show also. So this is, you can see. You can see these are JTAGs. So this is specially designed. This is specially designed what? To transfer the code. Now this side you are going to connect in your computer. This side you are going to connect your computer. So how basically it will be? Also this you can see, this is also one JTAG. This is also one JTAG. This is also one JTAG. So how, this is one communication protocol. Okay. So how you are going to do basically? So this is my computer. This is my PC where this is my PC where I have what? LED dot hex is there. This is my PC where my LED hex is there. This is my microcontroller. This is my microcontroller. So this is my microcontroller. Now you need to put this code, you need to put this LED hex into microcontroller. Then only your microcontroller will work. Am I correct? Directly you cannot put. You need some interface. So in between you are using JTAG. In between you are using JTAG is one debugger or one debugger. Not only JTAG, there are so many devices also there. I'm just giving a simple example. So what you'll do, now from PC you will connect here. Now JTAG will take the data through communication protocol. Again, it will put here into microcontroller. So this is the medium through any JTAG communication they are doing it. Also, there are some other communication also there like I2C, SPI. In my current company, in my HPE, whenever we are flashing the code, whenever we are putting the code into the microcontroller, we are using SPI communication. So different communication methods are there, so that you are going to use on hardware, and that hardware will take the code from PC and it will take and it will put into the microcontroller. This method is called flashing. And also by using JTAG, you can do debugging. Only flashing is not possible. One more thing is possible also, that is debugging. That means why debugging required? Suppose you have written the code, tomorrow that code is not working. You need to check, right? Where this code is getting stuck. Suppose you are writing 100 lines of code, it's fine. Line by line you can go and you can check it where it is not working. But suppose you have thousands of files and each file have thousands of lines of code. In that case, it is very difficult to go line by line and check, right? So in this case, we generally go for debugging, and that debugging you can do by using JTAG. Okay, that debugging you can do by using JTAG. So also how other kind of debugging are there. Today I'll tell. Today I'll explain. You need to telling something. Kill generates hex file when project is compiled. Yes. How to generate hex file, sir? Okay, fine. Okay, I will do one more project now. So every project I'll give little more information. So now I hope everybody clear how we are going to flashing. Next project I'll go to show you how you will do the debugging also. Flashing is done, then how you will do debugging also. Next project we will do little big. So what we will do? The next project I'm going to interface input device. I'm going to interface input device along with output device. I'm going to interface input device along with I'm going to interface also output device. Now, the requirement is I have my microcontroller 8089C51. I have the microcontroller. What microcontroller using? 8089C51. Okay. Is kill necessary to debug in debug Proteus? Is kill necessary to debug? No, kill. Why kill necessary? Without kill, you cannot generate your hex file. Without kill, you can develop the code, right? You can develop the code by opening any editor. You can develop the code, but how you will that code you will compile? What is compilation? Compilation means the compiler will convert your low level language or high level language into machine level language, because your computer can only understand machine level language, and that is possible by using kill. Not only kill, there are so many platforms are there, but we are choosing kill. Kill is one platform, and by using kill we can do it. Actually you can debug software logic using kill also. That also I'm going to show. Okay, that also I'll show you. We can debug the software logic using kill also. That also I'll show here. Don't worry. So 8089C51. So now the project is I'm going to use two switch. I'm going to use two switch. This is my switch. I'm going to use two switch. Okay, this is my switch 1 and this is my switch 2. Wherever you want, you can connect. Okay. Also, for Proteus without kill, what options? Any option you can choose where you can build your file and where you'll get .hex file. There are multiple platforms out there. You can choose any one of platform. But for generally 8051 microcontroller, we use kill platform. For that reason, we are using kill. In kill, we'll build the software and we'll find the binary code. We'll file the machine level code. That machine level code is nothing but .hex file. For that reason, we are using kill. In Proteus, you cannot generate .hex file. Proteus is only the software where you can do the simulations, where you can do the output. Are you clear? Subhangi Joshi, are you clear? I hope you are clear with my statement. Okay, awesome. Now, what we will do, we are going to also use two devices. One is we are using LED. One you are using LED. And one more you are using one DC motor. One DC motor. Using one DC motor. This is my DC motor. So this is my LED and this is my DC motor. So everybody know that, okay, how LED is working. Then what is DC motor principle? DC motor principle is very simple. So it's a motor which don't have any polarity. So basically DC motor don't have any polarity. Suppose this is my DC motor. Now suppose you have one battery. Suppose you have one 5-volt DC battery. Now if you have one 5-volt DC battery. So this is my one 5-volt DC battery. Now in this 5-volt DC battery, suppose this is your VCC, or if you see in the battery, if it is written plus, that means it is VCC, and one is minus, that means it is ground. So now if you connect this VCC here and this ground here, your motor will rotate in these directions, right? Again same way, this is your these things. Now again same motor you are taking again same motor, and now if you go here, again same 5-volt battery, but if you change the polarity, now here you will do minus, that means ground, and here if you do plus, that means VCC. Now if you connect here, so it will rotate in this direction. So depends on the input, it will change the things. Positive means what? VCC. Means 5-volt, means 1. Negative means what? Ground. That means this is 0. Positive means what? VCC, 5-volt. Negative means what? Ground. So in this way, your DC motor will work. Now my next question is how switch will work. My next question is how switch will work. Now this is my switch, you can see here. This is my switch. This is suppose connected P1. So this is connected P1 underscore 0. And this is connected in P1 underscore 1. This is connected in P2 underscore 3. This is connected in P2 underscore 4. And this is connected in P2 underscore 5. Because DC motor have two terminals. Now, how switch will work? Switch always it will work in the opposite logic. Like sensors, switches, always it will work in opposite logic. That means here it is connected. Here already by default 5-volt is there. Here already by default 5-volt is there. Now, this is now open. This is now open. And whenever you press it, it will just touch with ground. Whenever you press with, it will touch with ground. And whenever it will touch with ground, that means a switch is pressed. Whenever it will touch with ground, that means switch is pressed. That means whenever it is going to 0, that time, whenever it is connected with 0, that time switch is pressed. Now tell me, in the opposite way, how you will get to know that your switch is pressed whenever it will touch with ground. Am I correct? So you can write this logic in this way. If your switch equal to 0, whenever it is true, this is one if loop. Whenever this condition is true, that means switch is pressed. Otherwise, switch is not pressed. Clear? Yeah, pull-up resistor required. Fine. So that is the different concept again, pull-up and pull-down resistor, because here all the pull-up resistors are there. So I'm not going to into that side. I'm now into software side. So I'm not going into pull-up and pull-down because only I have 1 hour 10 minutes time in my hand. I need to finish another two topics. I don't know, but yeah, we'll see. So this is the things. So this is the scenario. So now how you will do the program. So how you will do the program. Okay. Now again, I'm doing from the starting. Who all missed it? Again, I'm doing from starting. I'm creating a new folder, 3-number project, where I have LED, I have DC motor, I have switch. This is the again I'm creating 5 folders as I told. As a so every time whenever I'm doing these things. I'm creating 5 folders, app, include, then bin, pin, then your WSP, then SRC. Again, same procedure I'm following. Same procedure I'm following. Now I'll go to kill. I'll start with what? What I'll do? I'll go to project. Again, new microvision project. What I'll do? I'll go to LED DC motor switch. I'll click on that. Now I'll go to WSP folder. Then I'll give the project name LED motor switch. So now it will ask for which controller you are using. So my controller name is AT89C51. This is the product of microchip. I'm clicking on that. Okay. Then it's telling, do you want starter file? Yes, of course. In every project, every microcontroller, every time you want the starter file. Now I told I will go for the setting. We are using the frequency 11.0592. Then we are using ONCPROM to store this program. Then output, we are going to create hex file and we are going to store in bin folder. Then the last one here, we are not doing any code optimizations. We are not doing any code optimizations. And if you are including any driver, we can include the driver from input folder. Done. Now what I'll do, new. I'll save as main.c. I'll save as, sorry, not this is the project. This is the project. I'll save as main.c. Now, first, what is the first line? Has include register 51.h. Has include register 51.h. Now, how many devices you are using? How many devices you are using? You are using two switches, switch 1, switch 2, one LED and one DC motor. So that means for one switch, one pin, here one pin, two pins, for LED, one more pin, three pins, and for DC motor, two pins, five pins. Now you need to define these five pins first. Okay. So S bit, I can write switch 1 where it is connected. Switch 1 connected in P1 underscore 0. P1 caps operator 0. Then S bit, switch 2 where it is connected. P1 caps operator 1. This is done. Then I have connected also LED. S bit LED where we have connected. P2 caps operator. Which bit you are connected? We have connected 3. P2 3. Then we have DC motor. DC motor have two pins. One is S bit motor 1. Where it is connected? It is connected in P2 underscore 4. One more pin also there in motor. S bit motor underscore 2 equal to P2 caps operator 5. Okay. So these are the pins we are using. Then we'll start with void main. As I told, all the embedded system program you need to write under while one because always it should work. It should not run only for one time. It should run continuously every time. So simple. I'll give the conditions. If there are two switch, if switch 1 equal to 0, that means if switch 1 is pressed, what you are doing? If switch 1 is pressed, you are on the LED. If switch 2 is pressed, that time your DC motor is on, right? So if switch 1 is pressed, I can write LED equal to 1. Else, LED equal to 0. Simple. This is the first condition done. If switch 1 is pressed, whenever switch 1 will press, that will connect to 0. That time it will become true. So when now we'll check if switch 1 equal to 0. If it is true, it will go inside the if block. Otherwise, it will not go inside the if block. It will go inside the if block. Otherwise, it will not go inside the if block. So now, next, If switch on equal to 0, then LED 1, otherwise LED 0. Same way, if switch 2 equal to 0, that time your motor is on. So motor is on means any one side you can make it on. So either you can give this bit as 1, this bit is 0. That means P2 underscore 4 is 1. P2 underscore 4 is 1. P2 underscore 5 is 0. So now what I will do here, this is the things. Motor 1, I'll write 1 equal to 1 and other pin equal to 0, because to run one motor, one side should be positive and one side should be ground. Else, if switch 2 is not pressed, then both the values are 0. Everyone understood this point? Only, we are not doing anything. Only we are just playing with 1, 0, 1, 0. We are just playing 1, 0, nothing. Wherever you have connected, that pin either you are making 1 or that pin you are making it 0. That is nothing but embedded system. Clear everybody this point? Everybody up to clear? Are you clear or not clear? Clear? Yeah, sorry, motor 2, sorry. Yeah, you are correct. Okay. Motor 2, motor. Now done. This is my program is done. Again, see, if this program I'm not adding here, if this program I'm not adding here in the source group, it is not allowing for me the compilation. So first you need to add whatever .c file you have in the project. First you need to add it. First you need to add it. So main.c you need to add, then it will go for compilations. Now someone was asking, see, till now if you'll go to there, if you'll go to bin folder, there is no hex file created. Only whenever you will do the compile button, that time it is first checking for the errors. Then whenever I'm compiling against next one, it is telling now hex file is created in this folder. For that reason, kill is required. Kill is only the platform where we can implement the software, Now, if you'll go here, you can see this hex file. You can see this hex file is created. You can see this hex file is created. Just give me 30 seconds. Yeah. So now by using kill software, we are creating the hex file. So you are creating the hex file. Now I'll just do the again simulations. So sir, please make us to do step by step. Okay, I'll give time. Just I'll finish this ones. Then I'll give time for 5 to 10 minutes where I'll give you time to do one project step by step. Is it fine for everyone? Yes? Let me finish this. Then I'll give time. Then you can do project for 5-10 minutes step by step. Now, fine. So now this is the Proteus. I'm deleting it. I don't require now. Again, I'll start a fresh one. Okay. So again, I'll go to P. I'll go to component mode. Again, I'll go to P and I'll go to component mode. So here I'll search AT89C51. This is my microcontroller. This is my microcontroller name. So first I'll search AT89C51. Okay, done. So now this is my things. Now I want switch first. Then you go here, click switch. Switch is selected here. You can see switch. Just do OK. automatically switch will come here. Now click here, then click here. Where switch is connected? P101 switch, right? Again, click the switch, go here. Yes, exactly. Your question is correct. For that reason, I told. Now the next is that I'm going to do that one. Generally, what will follow in the industry. Okay. So you asked one good questions. Manpreet Kaur, each device connected to a pin needs its own S bit. Is there any shortcut method to define all in one command? This is the next target that I'll tell, so that any controller you are going to use will do it. I'll come to your questions. Okay. So now, so this is my two switches I have there. This is my two switches I have there. So now first I'll connect the ground two switches. I'll go to ground here. I'll connect the ground here. Now here, done. Then again I'll go to component mode where I'll search LED. Where I'll search LED. Okay. Then I'm going to connect LED here. You can also rotate. So one side I'll connect the LED, sorry, where it is there. If you go to my code, it is connected in 3, port to 3 number pin. So now we have one DC motor. Just click on here, just type DC motor. Simple DC motor model. Here, this is the DC motor. One side you are connecting phone number pin. One side you are connecting type number pin. Then you will go to ground. Then you will go to ground. Here I'll connect to ground. So everybody clear now. Design is done. So now design is done. So LED is connected to 2.2. So okay, so we'll see what is where it is connected. It is connected into, I think, 2, 3. It is connected into 3, right? Port to 3 number pin, port to 4 number pin, port to 5 number pin. So we have connected port to 3 number pin, port to 4 number pin, port to 5 number pin. Yes. So this is my design done. Now, if I'll play it, by default, all the pins are high. For that reason, this is on. Now, once I'll upload the code. Now, this is my code. Now I have created my hex file. Again, here what I'll do, I'll double click on that. I'll double click on that. Then go for program files. Go for program files. And where is your code is there? Where your code is present? Your code is present in bin folder. Click on this LED motor switch. Click on this open. Now you click here. One minute. It will work in a system. My Proteus got crashed, but once you'll do it, once you'll press this, your LED should on. Once you'll press this, your DC motor should on. Okay. Meanwhile, I'll show first this debugging in the kill itself. Then I'll come to Proteus. I'll check whenever I'll give time to you guys. Whenever you'll do it, I'll check my Proteus got crashed. Okay. So now what I'll do, somebody also asked me somebody also asked me that. Okay, so without Proteus we can do debugging here. Okay, so without Proteus also we can do debugging here. Proteus is not mainly for debugging. Proteus is not mainly for debugging. Proteus is for simulations. In Proteus we can see our output, either whatever program we have written, either this is correct or not. So that purpose we are using Proteus. Now what we will do here, you can see here how you can debug here itself. How you can debug here itself. Before going to here, I just want to ask one thing to management. Sujismita, are you there? Or
Yes,
any?
sir. I am here. I am here.
Okay, so I think in next 1 hour we cannot finish our topics because
Okay.
faculty they want to know next thing, the advanced thing. So today we'll proceed up to 8 o'clock. If all faculties are okay, then we can extend this workshop up to one more day. I hope if everybody fine, I'm also okay to share my knowledge. So you can have the poll also meanwhile, so that we'll go a little slow, because in faster way if you'll go, there is no use, either they will not understand it properly. So I require from your side, you can take the decision, and for that reason you can make a poll also if you want. Okay. Again, I'm handovering to myself. Yeah. So now how you will do the debugging. Okay. So now how you will do the debugging. So you can see here. Here there is an option called start or stop debug sessions. Here there is an option called start or stop debug sessions. Or either you can go here, you can go to debug. Here you can do start or stop debug sessions. Here either you can do debug, you can do start or stop debug sessions. That is the one point. Second point is also here also there is a start or debug options. This is the shortcut key, and this is not shortcut key. From here you will go, you will search it. Both are same. So I'll just click on that. Whenever I'll click on that, it will go here. It will go in this way. Okay. So what we are using in your program, we are using port 1, we are using port 2. So what you will do, go to peripherals here, go to peripherals. Whatever peripherals you are using, you can see you have timer also here, you have serial communication also here, we have interrupts also here. So as of now, we are using port 1 and port 2. We are using port 1, click on that, you take here. Then go to peripheral, click on that port 2. We have port 2, also you take here. Now you will see. Now what you will do, here you can see here. The meaning is that, see here, RST, if you click on that, it will go step by step. It will go line by line. Okay. Remember one thing, your program execution will always start from void main. Your compilation will start from top to bottom. Your compilation will start from top to bottom, but your program execution will start from void main. For that reason, whenever I started, directly it will come to these positions, void main, while one. Simple. While one is always true, it will come to here now. Now, if we'll go step by step process here, now I'll go step by step process. Okay. If we'll click this one, then it will go step by step process. If we'll click this one, then it will step over. What is the meaning of step over? Now in your program, suppose there are 5 lines. So you can give step by step, you can go step by step, you can do it. Step over means that will do next. So first we will go step by step. When I go step by step, where you went? It went to, you can see, it went to LED 0, because if you see, what is the condition in 13 number line? Switch 1 equal to 0. If you see where switch 1 is connected, P1 0. You can see P1 0, still now it is 1. 1 means switch is not pressed. For that reason, it went to else part. Again, you do. It will check now if switch 2 equal to 0. You can see switch 2 also connected in P1 1. Switch 2 also connected in P1 1. So now switch 2 is there in P1 1. That also switch is not pressed, because you are seeing here 1 is there. Tick means 1. If there is no tick means 0. Okay. Now, if we'll enter, if we'll step over, you can see where it is going, motor 1 0. Where motor 1 connected? Okay, motor 1 in motor 1 connected where? You can see this is the motor 1 connections. Okay, I'll go from the starting. I hope you got confused again. I'll go from the starting. Okay. Click on this, start, stop, debug sessions. I'm going from starting again, guys. Everybody see here. So while 1, then if switch 1 equal to 0. Now switch 1 is not pressed. Switch 1 is not pressed. Means switch on pressed means this value will become 0. If not pressed means this value will become 1. Tick is there means the value is 1. Tick is not there means value is 0. Now switch on is pressed. I'll just run it. Now where it went? LED equal to 0. Now if we'll end, now switch on is not pressed. It went to LED equal to 0. If I click one more, now you can see LED where it is connected. It is connected in where? P3, P23. Port 2, 3 number pin. Port 2, 3 number pin is 0. Clear? Now again if I'll do next, it is going to else part. Again I will click motor 1 equal to 0. Now motor 1 also will become 0. P24. If I'll click one more time, this also will become 0. That means always it is going to else part, else part, else part. Okay. Now again I'll start from the starting. Again I'll start from the starting. Now what I'll do by forcefully what I'll do, I'll make it 0. That means switch on is pressed. Yes or no? That means switch on is pressed. Now switch on is pressed. That means now line number 15 should execute. Line number 15 should execute. This was 0 now. This was 0 and now it will become 1. This was 0 and it will become 1. If we press again, you can see it will become 1 because switch on is pressed, so LED is on. Now what I'll do, I'll press switch 2 also. Now switch 2 also pressed. Now switch 2 also pressed. I'll click on that. It is going into E block. It is going into E block. Now it will go inside the E block because this condition is true because switch is pressed. This condition is true. Now motor 1 will become 1. It was 0. Now it will become 1. It was 0. Now it will become 1. No, it will not become 0 because this value is 0 itself, right? So this will become 0. Clear? So step by step, you can check where your code is not working. Suppose in some place your code is not working, you can go step by step and you can see here. Then what is the step over? You can give your, suppose directly you don't want to run this one, directly you want to run this one. Then you can see here, this is called insert or remove breakpoint. This is called insert or remove breakpoint. That means if you click on this, you can see here, I am setting the breakpoint here. I'm setting the breakpoint in line number 22. Now, when I'll press this one, directly it will go to, if I'll press this one, not this one, directly it will go to here. Directly it will go to here and from there it will start running. So that is called watch point or breakpoint. That is called watch point or breakpoint. By using that, wherever your program execution should start and wherever your program execution will stop, you can control that by using this breakpoint. Clear? Cost of time or concept, all the concept I'll tell. Okay, everybody clear up to this, how to do debugging? I hope everyone clear how to do debugging or not clear. If clear, then I'll go for the next one. So you want some time, you want some 5 minutes time so that you can do one project. Do you want some 5 minutes time so that you'll do the project? Recorded video you can check with management. I think she will give you the clarification about that. So Smita, she will give the clarification about the recording video, so you can ask her.
Sir, we will be providing the recorded sessions, so we can discuss at the end of this session. I'll guide you through it.
Not required. How to give VCC and ground in Proteus at pin 40 and 20. Okay, how to give I'll show you, but this is not required. How to give that I'll show you, but VCC and simple thing, right? This is my ground. So if you want where you first of all see, you can see your 40 pin will be not there here because this is not required. It's a simulations. Simulation giving to hardware, giving VCC and supply, there is no meaning. So, but whenever you require ground, you can give ground this one. Whenever you can give VCC, this is the power. You can give VCC this one. This is VCC. Power is nothing but VCC. This is nothing but ground. Clear? I want to show you this project, but my Proteus is not working. But 1 minute, what I'll do? I'll just remove this some issue here. No, some problem in there. My Proteus for that reason it's not working. But if you'll do the program, what it will do, right? It will work. Once you press switch one, your LED on. Once you press switch two, your DC motor will on. So if you have any existing one, I can show you. Yeah, how it should work, I'll show you. So that you will get the output in this way. If you press switch one, sorry. Yeah, if you press switch one, your LED should on, and whenever you press switch two, your DC motor should on. So it should work in this way. Whenever you will complete your project. Clear? So I'll come to, so guys, you want to do one project yourself? Will I give time or how it will be? Or will I proceed for next? Okay, from somebody asked me the questions. Okay, proceed next one.
So
Okay,
we
fine.
have, if professors, if we have any questions here, we can take some questions, and for the second half, Sasha sir will continue.
Okay, so somebody is asking from where, what is the questions? I just go through once. And so we want to do one project. Notice installation done. Next steps. In next file, we want to do one project. Please book in my kill my X file is not stored in the bin folder? Because you need to give the path. For Nilesh, so this is the questions. You need to give the path. You can see here. If you go here in the output folder, you need to set this. You need to go here, go to setting, go to output. You need to create hex file. You need to create the hex file and you need to give the folder path here. You need to give the bin folder path here so that your in your bin folder it will store. I hope Nilesh, you are clear. Yes. And one more questions. Somebody asked. What is from where switch taken, sir? Okay. From where switch taken? Simple. You go here. Click on P. Just type switch. Just type switch. It will be there somewhere. Okay. It will be there somewhere. So I because I'm doing regularly. So what you will do, right? So you can directly make it okay. Switch will come. Okay. Directly make it okay. Switch will come. Switch will clear from here. And somebody asked me the very good question. So I forgot name. That for 10 devices, how many times you will write SB? Am I correct? Somebody this question asked me. Okay, cool. Now, can we directly flash hex code kill with the help of? Can we directly flash hex code kill with the help of JTAG or ISPs? You can. That JTAG or ISP, whatever you're talking about, these are the tools. By using that, you can flash the hex code directly. If you have the hex code, you can directly flash. For that, no need to do. They have their own software. It will take care. Okay, we'll go next. We'll continue next, guys. Okay, so in this way, basically, we can do so many projects. We can do so many projects. Okay, I'll come to your questions. That question you asked me that if you are using 10 devices, then for that 10 devices, are you going to use SBIT or not? Or how many SBIT you are going to use? Okay. So if you see this code, you are using SBIT, right? SBIT, 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 SBIT. So this code is only for 8051 controller. This code is only for 8051 controller. Okay. For that reason, we are using it. For that reason, we are using SBIT. But generally, whenever we write the code in the industry, we don't use SBIT. Then how we'll do it? This is a little C concept. So how we'll do it? We'll do it. Okay. As you ask me the questions, I'll show you how you'll do it. Fine. So this is one registers. Okay. This is my suppose I'll talk about P2. P2 is a register. So there are how many pins are there? P2 is a register. There are how many pins are there? Total there are 8 pins are there. That means it's a 8-bit register. This is one 8-bit register. So this is one 8-bit register. Directly now we'll do the coding in register. So now suppose we are connecting the LED here. Now you are connecting the LED here. Again, I'm telling this concept everybody may understand or not understand because this is purely C concept. But still I'll try to tell you as you ask the questions. So I'll tell you generally how we'll write the code without using SBIT. And if you learn this 5 minutes process, whatever I'm telling in this next 5-minute process, you can write the code for any controller. The format is same everywhere. Tomorrow you can write the code in AVR controller. Tomorrow you can write the code in peak microcontroller. Tomorrow you can write the code in ARM controller by using the same format. So try to understand if you are okay. So now this is a P2 register. This is my bit number 0, bit number 1, bit number 2. This is my bit number 3. This is my bit number 4. This is my bit number 5, bit number 6, and bit number 7. So this is my bit number 7. Now this is my bit number 7. Now I want to connect my LED in bit number 2 and I want to on it. I want to on it. Clear? This is my requirement. That means if you will give this pin is 1, your LED will become on. Am I correct? Yes. In software, if you will give this pin as 1, I'll give this LED will become on. So there are some concept called bitwise operators. So bitwise operators, that is a bitwise operator called bitwise OR. If we will do OR operation with this bit 1, then the output will become 1. Simple. This output will become 1. That means I don't know what is the value here. So simple. This is the case I will take. Either this value is 0 or 1. I don't know. Either it may be this value is 0 or this may be 1. I don't know. But if I do OR operation with 1, what value you will get? You will get 1. Am I correct? Yes or no? Now, if I'll do this bit, in this bit, if I'll do 1 with OR operation with 1, then your output you will get 1. So how you will get this one? How you will get this one? Very simple. Completely C concept. So now you can take what? You can take 1. So this is my 1. If I'll convert 1 into binary values, you will get this value. You will get this value everywhere 0, 0, 0, 0, and the last value 1. Now I want this value, this one should come to this position. This one should come to this position. What you'll do? If you'll do left shift 2 times, 1, 2, then this value will become 1, this value 0, 0. This is bitwise operations, which is very important for embedded system. If anybody wants to make career in embedded system, this is the first topic they should be very clear. Otherwise, it's very difficult. So now, if I'll do OR operation with this, so what will happen? So whatever value will be there here, if it is star, same star will come here, either 0 or 1. If it is star, same star will come here. If it's 2 star, same star will come here. If it is there anything, 0 or 1 is there, same value will come here. Whatever value is there, 0 or 1, same value will come here. Whatever here 0 or 1, but the value will get 1. That means this bit will become 1. This bit will become 1. So then what I did, I did P2 equal to P2 OR operation with 1 left shift 2 times. This I have done, right? Am I clear? Can a corrector firmware can be recovered using JTAG? Correct. Corrector firmware, it cannot be recovered by using JTAG, but by using JTAG, you can flash one more. By using JTAG, you can flash one more. What? By using JTAG, you can flash one more software so that your hardware can be recovered. So now, everybody clear this point? So what you have done? This you have done. So that is a concept called macro. In C, there is a concept called macro. As you asked me this point, you can take it. Really, this will help you if you're doing something in embedded system. One concept is called macro. What is that? If I'm writing hash define A10, that means the meaning is that wherever it will see 8, it will just replace with 10. In void main, what you'll do, others, just give me 2 minutes. I'll complete this topic, then we'll move forward to the next topic. So now if I'll print percentile TA, then it will just print with 10. It will just print with 10. Okay. Same way you can define our macro has define set bit. This is one macro defining. I'm giving the register. I'm giving the bit position. Which bit position you want to on. Register equal to register or operation with one left shift bit position. Same thing I have written, right? Whatever things I have written here, same thing I have written or not? P2 equal to P2 or operation one left shift two times. That means register equal to register or operation with one left shift. Which bit you want? Either you want to make 2 bit on or bit 3 on or bit 4 on. Directly which bit you want, you can do it. Okay. Now, this is the thing. So this is the macro. Now, what you will do, if you will define in any header file, if you will define in a header file, now I don't have that much time to create any header file. So I'm sorry, guys. So directly we can write here. Now, no need to write S bit. Directly what you'll do, if you'll this statement here, if you'll this statement here, if you'll give this statement here, which register you are using? P2. Which bit you are using? Bit 3. Done. All these things skip. Everything not required. That means you are making on that bit. Simple. If you want to clear it, for that also you will define one more macro. Everywhere, every program you will do the same thing. Now S bit not required. Today you are using AVR microcontroller. Today you are using 8051 microcontroller. You will give 8051 microcontroller register name. Tomorrow you are giving AVR microcontroller. You will give AVR microcontroller register name. Tomorrow you are using ARM microcontroller. You will give ARM microcontroller register name. In this way you can do the coding. How? In this way also we generally do the programming in industry. So this is the correct way if you want to do in a proper way so that it should be used everywhere. I hope clear. I hope clear this point. Shifting of n bit is in code how? Shifting of nth bit, you can, nth bit means whatever bit you want. Which bit you want. Nth bit means suppose now you are telling now you want to connect the LED here, then you do 2 bits. If you want to connect LED here, then you do 5th bit. If you want to connect LED here, then you will do 7th bit. So you can change here. For that reason I made it generic. Which register, which bit. Now P2 register, 3rd number bit. Tomorrow you are telling I'm connecting the motor P2 register. Tomorrow I'm telling I'm connecting the motor in P2 register 4 number pin. So you can give 4 number pin. Clear? Clear? Yeah. Can we want 2 LED with different pin in P2? Can we want 2 LED with I did not get your questions. Can we want 2 LED with different pin in P2? 2 LED with different in P2 means you can see very simple questions here. Now we have pins are there. Wherever you want, how many LED you want, you can connect. Can we connect 2 LED in different two? Yeah, you can connect. What is the problem? 2 LED, 2 devices. 1 LED, 1 device. 2 LED, 2 device. You can connect up to 32 devices. Simple. Clear? I hope clear up to this. So now also I was talking about debugging. Okay. I was also talking about debugging. One more very good way of debugging is what? Suppose you're writing any code. Suppose you're writing any code, right? Either this code is work or not. So always give the printf statement. In your program, you can give the printf statement. You can give enter. Then also you can tell what is the A value. What is the A value? You can say. So this is also one more debugging way where generally you can enter printf statement. Suppose you have multiple line of code. I'll show you one project. I'll show you one project here. Okay, so by using that, you can do also so many kind of projects. I'll show you one demo, one project by using GPIOs. This is one project I have created. Okay, so this is one project I have created by using Proteus and simple C code. The project is that this system I am created, and this system you are putting in front of your door. This system you are putting in front of your door. If you are putting the correct password, then your door will open. If you are not putting correct password, then your door will not open. And what will happen? If you are putting wrong password for 3 times, that is a buzzer, it will give sound. You can enhance up to IoT. It can also send the notification to the house owner. Okay. Now, if you run it, it is telling for password-based door locking system. So my password is 1234. If I pressing 2365, it is telling your password is not correct. Again, it will ask for password. Again, it is telling your password is wrong. Again, if you put the wrong password, that time your buzzer will give sound. So it will give ting 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 sound, so that everybody will get to know that okay, somebody came and tried to do something. So if you put the correct password 1234, then your door will open or your door will close. Your door will open or door will close. So basically, why I'm showing this project? In the college days, in college, engineering colleges, if some students, they can do this kind of small minor project in second year itself, then it will be really helpful to make their career in the future. So by same using GPIO, I have connected LCD, I have connected motors, I have connected keypad. Also, they can do it. So this is one project. And if you see this project code, if you see this project code, what will happen? This is the code we have written. I have written. So suppose the problem is, suppose in this line, output is not coming. In this line, the output is not coming. So how will debug it? How you will debug it? In this line, what you can do? You can give one printf statement. What printf statement will give? Either enter phase 1. Now, that means now, whenever your project will run, if this statement is coming, means your project flow is coming up to this. Same way you can give multiple statement, printf statement in the multiple places, and you can debug the code. You can debug the code. Clear? So how you can also do debugging? Also in this way you can do the debugging. In actual execution and microcontrol, how printf work? It will work. So how printf work means, so for that you require one console. You require one console. So here your questions you have asked in actual execution on microcontroller, how printf works. We need to display on LCD. There are multiple ways. Either you can display on LCD, or you can display in the serial terminal, or you can display in the by using serial communication protocol. You can display on terminal. Clear? Either you can use LCD, or you can display on the else, or you can display on the serial terminal. Actually, that was my intention that okay, today one more project I'll do how serial communication will work and how you can display the data in serial consoles, how you can take the data from keyboard and you can show it. But I think time is not there to do that project. And if I'll start this project, it will take minimum of 30 minutes. So I'm not going through that. I'll just tell the concepts about timer counter, about the interrupt, and about the serial communication. So that coding, I'll I'll not go for that coding, but these concepts I'll tell you. What is timer counter and what is interrupt? And somebody asked about the watchdog timer. Then what is serial communications? You asked. Not even UART, there are different serial communications are there. UART is there, I2C is there, and SPI is there. So these are the topics I'll just tell. Give me just 2 minutes time. I'll just take some water, then I'll come back.
Sir, are you trying to say something? Sashwat sir?
Oh, sorry. I was telling
Yes,
what,
yes.
okay, no issues, okay. So what is timer? Okay, first topic is what is timer or counter. So what is timer or what is counter? So what you know, what you are understanding about that, okay? So timer counter means whenever we are generating delay, that time generally we use for timers. And whenever we generally go for counting operation, that time we will go for counter. So if you'll see in Arduino, all these things, they are writing some for loop, I equal to 0, I equal to 0, then I less than 1000, then I plus plus. They are writing this loop and they are generating the delay. This is not the actual way to generate delay. The problem what will happen, this code today we are using 8051 microcontroller to execute one instructions in 8089S51. It is taking 11.085251 microsecond. This is the time it is taking. So that means to execute an instruction, it is taking this much time. Now this loop will run for 1000 times. This loop will run for 1000 times. So that means this many, what is the calculation will come? That many delay it will generate. Now, if you are putting same code in AVR microcontroller or in any microcontroller, that time will be very less, maybe 0.76 something microsecond. And if you are doing into multiply 1000, that time you will get some little time delay. Okay. So for delay generations, if you are using delay function, that is fine. If you are doing some projects in your college, that is fine. But in the real time project, it will not work. So for that reason, we want timer concept. So by using timer, generally we will generate delay. And by using counter, we generally you do the counting operation. So example of timer is your generating delay. Example of timer is your generating delay. So next point is, what is that? Example of timer is your generating delay. An example of counter, where counter is used, your energy meter reading. In your home, you are using energy meter reading, right? There you are using counter. And where you are using counter, your heartbeat sensors, it is used counter. So basically, if you say the technical way, what is timer and what is counter? Timer generally runs in internal clock. So microcontroller have internal clock. So they have the crystal oscillators, they have the frequency. So always timer will run in internal clock, but counter always it will run in external clock. Okay, for that reason we use timer for delay generations. For that reason, we use counter for your, what is that called? Counting operation from where external signal is required. That is the concept of timer and counter. So what is watchdog timer then? What is watchdog timer? So watchdog timer will work as dog. Okay. Now, watchdog timer, what is that? Watchdog timer, what is that? Suppose this is my program. Suppose this is my program I have written. This is my program I have written. This is my program I have written. This is the program it is running. So it is running in my microcontroller. This is the program it is running in my microcontroller. So what will happen? So this line it is executing, this line executing, this line executing, this line executing. Suppose due to some problem, the program execution will stop here, hold here. It will hold for, it will hold for what? Suppose your program execution will stop here. Suppose your program execution stop here. What will happen? There is a watchdog timer. So there is a watchdog timer. So watchdog timer, what it will do? Watchdog timer, what it will do? So watchdog timer will set the time. Suppose we'll set the time as 5 millisecond. In watchdog timer, we'll set the time as 5 millisecond. Now, whenever the program execution will stop here, now watchdog timer will start counting 1 millisecond, 2 millisecond, 3 millisecond, 4 millisecond, 5 millisecond. Once 5 millisecond will reach, if still the program is there in this line, then watchdog timer will reset the program execution. Again, it will come out, your control will come out, and it will start from here. Again, it will come out, it will start from here. So the watchdog timer always monitors the program executions. The watchdog timer always monitor the program executions. If in some places, if it will stop, that time your watchdog timer will start counting whatever time limit we gave. And if will and watchdog timer will say that in that time limit, if your program execution is not going for the next, then it will just reset it. That is the job of watchdog timer. Yes, are you clear? Are you clear about the watchdog timer? Now the next is I'll go for interrupt. This is very important topic. Very, very important topic. Whenever also we generally take interviews in companies. If somebody will tell that, okay, I knew embedded system, my first question will always interrupt. What is interrupt? What is that? So what is interrupt or what is that? So interrupt is very simple. Yeah, given everywhere. I'll tell you, whenever we are nowadays writing the code, okay, given practical situations where we require watchdog timer, simple thing. Your vehicle is there, right? Your vehicle is there. Now inside the vehicle software is running. Now, what will happen? In one place of the program execution will stop. Then that time accident happened. What will happen? It will not go into the airbag code. Where we have written the code for airbag module, right? Where when suddenly accident will happen, your airbag should on, your airbag should open, so that people will they will excuse from there, right? People will not means during accident your airbag should open. Now what will happen if your program flow is running and in some places it is stopped, next line of program execution is not executing. Now accident happen, your airbag will not open. For due to this critical scenario, due to this kind of critical scenario, if it cannot reach, this is a very simple example where we will use for watchdog timer. Watchdog timer, now any system we are making, now every system we are giving the feature of watchdog timer. Every system, every microcontroller, we are giving the features of watchdog timer so that in somewhere if it will stop, then it should recover. Clear? I hope I means you are clear, right? We need to reset in software before 5 milliseconds. No, we will software will get reset after 5 milliseconds, not before. Means same. In that 5 millisecond, if the program will not in that 5 millisecond, the program will not go for the next step. Simple. Once timeline is done, it will do the reset. Clear? Now the concept is interrupt. What is interrupt? This is very my favorite topic. Whenever I'll teach interrupt to students, I'm always happy. This is my favorite topic, interrupt. And also whenever you will code the writing for interrupts and whenever you will do the practical also, right? You will enjoy that interrupt. You'll feel how interrupt is coming. Okay. So what is interrupt? I'll give an example how interrupt will work. So interrupt, suppose you are listening music. You are listening music now in your home. In your mobile phone, you are listening music. Suppose your friend will call or from your home, somebody called you. Then what will happen? Automatically, the music will get stopped. Automatically, the music will get stopped. And what will happen? You are going to receive the call. Once your call again finished, your music will resume. Yes or no? That is interrupt. That is interrupt. That is interrupt. So basically, what is interrupt? I'll just explain in the technical way. Whatever I told, that is just for understanding. But what is interrupt? Is that I can remove it, right? Okay, what is interrupt? So again, this is my program I'm writing. Okay, this is the program I have written. This program is running inside my microcontroller. This program we have running inside my microcontroller. So these are the program I have running inside my microcontroller. Okay, this many lines program we are running. Okay, now this line we are executing. Then this line we are executing. This line is going here. This line is going. Now what will happen? Interrupt will come. What is interrupt? What somebody is telling what is interrupt? So this is my internal event, whatever code you have written on inside while one, right? You must understood that what is while one. So this code you have written inside while one. This code you have written inside while one. This code you have written inside while one. So whatever code in while one, this is your internal thing. So this is your normal program execution. So this is I can say this is my internal event. This is my internal work. So I can say this is my internal event. This is my internal event. Now, then what is interrupt? Interrupt is not part of internal event. Remember, interrupt is not part of internal event. Whenever you will write the program for interrupt or whenever you will design for interrupt, it is not part of internal event. It's an external event. It is one external event. So this is one external event. Okay. So then what is interrupt? Interrupt is nothing but ISR. ISR, interrupt service routine. The meaning of ISR is what to do, when to do, and where to do. The meaning of ISR is what to do, when to do, and where to do. That means this is one external event, like your mobile phone call. Your mobile phone call is not part of your main programming. Your part of main programming is your listening music. So same way, this is the external event will come. So this is the external event. Suppose this external event will hit here. In these positions, it will come to your main program, to your internal program. So now that time it will check for the priority, which has the highest priority. It will check for the priority, which is the more priority. Either this external event has the more priority or your internal event is the more priority. Either your song is more priority or your call is more priority. Now if it will see that, okay, your external event has the more priority. Now it will see that your external event has the more priority. Now what will happen? There is a program counter. There is a program counter in your microcontroller. There is a program counter. What program counter will tell? Program counter will tell what is the next instruction I'm going to execute. What is the next instruction? Always it will store the address of next instructions. What is the next instruction I'm going to execute? That address, program counter always stores the information. Now program counter have this address. This is the line. Now I'll execute it. So what it will do? There is one stack pointer. There is one stack pointer in your microcontroller. There is one stack pointer. Now what program counter will do? Now it will see that interrupt has the highest priority. Your external event has the highest priority. Now it will stop the internal program execution. Now it will stop the internal program execution. What it will do? Now program counter will take this information. What is the next line I'm going to execute? It will put in the stack pointer. It will store the data in the stack pointer. Now this address, suppose the address is 0x80. Suppose the address is 0x80. In this line, my program stopped. So same 0x80 address, it will put here now. So now same 0x80 address, it will put here now. So now your internal program execution stops. Now what will happen? Your external program execution starts here. Now your external program executions starts here. Now your external program execution will start here. Once it is done, everything is done, then your program counter will take back this information again, and it will resuming the internal program executions. It will resuming the internal program execution. So this is called interrupt. This is how it is happening in the program. This is how it is happening in the inside the registers. This is how it is happening inside the microcontroller. So one external event is there, internal event is there. If external event is coming, if it has the highest priority, then internal event program will stop executions. Then external event will start running. Once it is finished, again your internal event will come back. Internal event will start execute. So this process is called interrupt. Clear? Clear everyone, interrupt? Or not clear? Where it is used. Interrupt where it is used. Simple things I'll tell you. Interrupt where it is used. In your laptop, right? This is my laptop. Okay? This is my laptop. Everybody, you are seeing my laptop. Now I'm typing F. That is interrupt. Whenever I'm typing, it is forgetting all other activities. Your F is coming. That is the best example of interrupt. Whenever you're receiving the data from anything, right? Now you are doing D. This is the interrupt. It is forgetting everything. Whatever I'm typing, that is fast printing. This is interrupt. Interrupt means it's always fast. Your simple example. Again, same airbag will go. In the vehicle also, your multiple applications are running. But whenever there is an accident, suddenly your airbag will open. That is the example of interrupt. Because airbag is the highest priority. Whenever there is an accident, airbag has the highest priority. So all other activities, it will stop. Music stop, everything it will stop. Suddenly it will open the airbag. That is the example of interrupt. Clear? Interrupt enable and interrupt priority. These are the registers. These are the two registers of interrupt, IE and IP. By using interrupt enable, you can enable each interrupts. How many interrupts are there in 8051? By using interrupt priority, you can change the priority of interrupts. These are the two things. In the real-time projects. Yeah, in the real-time project I told, like sensors. Yeah, sensors. See, whenever now, so many things. In sensor also, you can interface interrupt. So whenever you want some data, which it should be taken fast, that time your sensor should be interrupt driven. So there are so many examples you can use interrupts. Okay. So in sensor you can use in any other system you can use, any other. I told wherever you'll see that, sir, we need to periodically clear watchdog time or watchdog counter or not. Otherwise, autonomous system also watchdog reset will happen. See, your watchdog counter will reset once your program execution will start from the starting, right? That time your watchdog counter will reset. Whenever you will reset the program execution, what is the meaning? It will reset all the register values. It will reset all the register values. Again, it will start from the starting. So periodically, no need to clear. Whenever it is, see, that depends how you are designing the software. How you are telling periodically you can clear, that also you can do it. Or in your system, whenever there is a reset, you can reset all the register values. So that depends purely on your implementation, how you have implemented the projects. According to that, you can write the program. Either you can periodically clear or directly whenever there is a reset, directly it will do it. Yes? Nilesh, am I clear? Okay, the last one. Till now, one more chapter is pending from my side. That is your real-time operating system. I could not touch even anything in operating system concept. So I'm sorry for that because time I'm also not getting. Okay, so now serial communications is the last topic I'll tell. Okay, serial communication means by using this, you can transfer the data from one device to another device. You can transfer the data from one device to another device. So there are so many communication protocols we generally use in the industry, but very well-known communication protocols, these three: UART, I2C, SPI. UART means Universal Asynchronous Receive and Transmit. I2C means Inter-Integrated Circuit. SPI means Serial to Peripheral Interface. These three communications are widely used in every domain. And one more communication protocol also we use, that is CAN, that is specific to automotive domain, that is specific to vehicle industry. But this UART, I2C, SPI communication, everywhere it is used. Your mobile phone, you are calling, you are sending the message. Inside that, you are using one GSM modem. That is the part of UART. Through UART communication, you are sending the data. Now, this is your laptop, right? This is your laptop, and this is a projector. Whenever you are connecting from laptop to projector through UART communications, there is a DB9 connector is there. So DB9 connector is purely based on UART communication protocol. Now, in different scenario, now in vehicles, you have connected the sensors. Okay, and sensor is taking the data and sending to microcontroller through I2C communication. You can send it. This is the full duplex communications. I2C is a half duplex communications, and SPI is a full duplex communication. So UART is a common UART low speed communication, I2C medium speed communication, SPI high speed communications. In which case you are going for UART? In which case you will go for I2C? In which case you will go for SPI? So whenever there is a longer distance communication, you will go for I2C communications because it's a medium range. Whenever you are doing communication in a board, in a microcontroller board, if you want to do any communications, you can go for SPI. It is very fast. And UART also depends on TX, RX, where you can interface based on purely for from one microcontroller you can connect so many different nodes. That means from one microcontroller you can send data, multiple data. I was working for CANs last 5-6 years when I was in Bosch, and this CAN protocol also is implemented by Bosch company only, Robot Bosch. So they have implemented it. So I was also working for 6 years in this CAN protocol. So from one microcontroller they have connected different nodes. That means microcontroller is a transmitter, nodes means your receiver. So it can send data to all the nodes. UART also important, UART communications, your I2C also important, SPI also important. All these communication modules are very, 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 very important. Okay. So yeah, of course, we have done all the things. Generally, whenever any students is taking under Sky Skill, we generally teach all these things from starting from GPI to serial communication, interrupt. We'll do the practicals, we'll do the drivers, We'll write the drivers, everything. And also we'll go for advanced course. And also we'll go for advanced course where also we'll go for your ARM controller. That also we generally cover it. So I'm a seasonal trainer in SkySkill. So basically, whenever there is a embedded system training opening is there in SkySkill, so I generally provide the training. So all these things we are covering in that topic. So I hope again I'm telling I'm really very sorry. Last one topic is pending. So last one topic is pending. So that is for what is that? Your real-time operating system. I could not cover. I thought also we'll do some more practicals based on serial communications, how you will send the data. Also, you can see here. So one more things I want to see. If you want to send your serial communication data, right? You can go here. This is the device you can see here. You'll see here. This is the device. You can use your oscilloscope. You can do the analysis in oscilloscope. This is my UR terminal. By using this, you can send the data. This is my SPI debugger. This is my I2C debugger. So everything you can do. So in your what is that called? In your Proteus design, you can interface all the devices. You are I2C, SPI, all the devices you can interface. So every practicals you can do by using this thing, by using these things. Okay. So if I have anything, I can show you. I hope I should have the UART one. I did not save the coding. Okay, no issues. But in 2 days, 4 hours, I think I have also covered a lot. So I don't know how many things you can, how many things you took it. So, but yeah, but I hope it will really help you. So if you are going to start something in embedded system, if you are going to start something in embedded system and make something in embedded system, it will really help you. It's a very short sessions where I cannot finish everything, but whatever your questions are there, I was going that, and whenever I'm coming out, I don't have any time to go for the next sessions. Okay, so yeah, so please, if you have any doubt, please let me know, and so that I can clarify. If you'll ask the doubt also, team will collect your questions and I can help you. And also my suggestion from my side also, as I am a working professional, and I am also working for SkySkill for the training. Whenever they have embedded system training, I generally give it. So if you have anything, in your mind, if you have any reference for your students, you can refer them to SkySkill so that I can take the training for them, and we can make the career for them. So that is also from request from our side, so that everybody can learn and everybody can grow at the same time. Yeah, thank you everyone.